Hi, everybody, and welcome to the 21st edition of Group Exhibit Hydrogen, Fuel Cells, and Batteries. I invite you to come and have a seat. Drinks on the house. My name is Marie-Hélène, but I have the great opportunity today to discuss new MSeries megawatt solution to address energy storage. Please help me welcome the President and CEO at Proton OnSite, Mr. Rob Friedland. Thank you for joining us.
Thank you for having me.
It's a pleasure. So Proton OnSite yesterday made a big announcement, the release of your MSeries electrolyzer. What should I get from that message?
So the way I would look at that is back in January we made an announcement saying that we had achieved full megawatt output capacity from our PEM system. So that was really the technology breakthrough. Well, with announcing what we did yesterday was the completion of the full validation of a 1 megawatt PEM electrolyzer. So you come to my facility tomorrow, you will see a full 1 megawatt system, all of the test data, all of the validation to complete it. So we are currently taking orders and have a commercial delivery schedule available for the megawatt. So it was really the launch of the product yesterday, and we've been in conversations, and now it's really something we're moving into the market with.
You actually have a great video showing the test facility where you made the complete analysis. Their booth is located at C70, which is right behind us. I invite you to go see that video that has actually pictures of this megawatt unit. You're talking megawatt. How big? 1, 2, 3?
Right. So what we're offering is a 1 megawatt and a 2 megawatt module. So in other words, to convert that's 200 cubic meters per hour or 400 cubic meters per hour of hydrogen, and that's operating at 30 bar pressure, and it can be either the base model essentially goes inside a building, but it's also been designed to be containerized if there's a reason why it needs to be containerized for a specific application. So those are the two building blocks that we have, a 1 megawatt and a 2 megawatt, and that's what we're bringing to market. For multiple megawatts, we'll use multiple units to scale up.
So for those that may not be familiar with the units, when you say 200 metric cube per hour, what does that translate into in terms of cars to refuel or something like that?
Right, so a 1 megawatt unit, 200 cubic meters, is approximately 420 kilograms a day. So if the average car takes about 4 kilograms, that's about 100 cars a day. 2 megawatts, similarly, would be about 200 cars a day. So clearly for the transportation market, that kind of size fits well in terms of what we'll need for throughput at a station for a very long time. So we anticipate continuing to ship our other smaller electrolyzers. We've been doing PEM electrolysis for 18 years. So for us, moving into this PEM platform is really an extension of our line of PEM electrolyzers, which go from 1 cubic meter to 6 cubic meters to 30 cubic meters and now to 200 cubic meters. So the scale-up factor as we've kind of grown to the megawatt size is in line with what we've done multiple times before. And we've also had our PEM electrolysis systems now in the field operating for over 14 years. So when you buy an electrolyzer from us, you're getting PEM technology in that cell stack that's been in the field for 14 years. So the reliability and the product realization has been something that's really an extension of what we've been doing all along.
So you just mentioned the expertise that Proton OnSite brings to the table, and the fact that even though it's a larger unit, it's built from years and years of experience in this product, ready to use, ready to purchase. But I remember about 2 years ago when the big talk was here about, well, we need electrolyzer. This is the next step in the technology, bigger electrolyzers so we can store renewable energies. You come 2 years later, you're there, you're ready. What is the next step for Proton OnSite? What do we see in the next 5 years? Is it bigger units as the next step, or?
Yeah, I think there are no real reasons why the units can't get bigger. PEM technology 10 years ago was always thought of as, well, it can only be small, and if you're going to go to any scale, you need to use alkaline technology or some other technology. Well, we and others have continually proved that that's incorrect. So I think with the 1 and the 2 megawatt system, certainly for the next 4 or 5 years in the marketplace, those are going to be perfectly fine. And for some markets, those are going to be fine for even longer than that. As we look to go bigger, there's no reason in our mind why a 5 megawatt or a 10 megawatt building block cannot be achieved, which would increase the size of our cell stack in our system. And again, that's something that we're perfectly comfortable doing at the right time as the markets really dictate. But again, this 1 and 2 megawatt platform has been designed to be competitively priced and to be moved into the marketplace and meet a multi-megawatt kind of scale. So with a 10 megawatt opportunity, we would use 5 of the 2 megawatt modules, and we see that still being competitive. So we don't feel a real reason to have to drive to a new cost level right away. So we're comfortable, but when the time does come, the scale up is something that we know we can handle, and we've already begun work on preliminary designs on our cell stack. Our key technology and our key experience is really in that PEM cell stack. We have specific technology and research capabilities to fundamentally design the elements within that stack that's pretty unique in the industry, and that will help us really scale it up when the time is right.
So before I touch on the pricing and the reception you received from I would like to remind everybody that this is a public forum, so feel free to ask any question. You just have to raise your hand and I'll come down with a microphone. But let's get back to the reception of your M-Series. Have you got good feeling from the public for now, like now that you've released this unit?
Yeah, it's been interesting as we when we made the first announcement in January, we started getting a significant amount of calls on more of an industrial side. So in the large-scale electrolysis world of float glass and hydrogenation and some of what's been served by very large alkaline technology, many of those customers have started to inquire on our systems due to the solid-state nature, very small footprint, safety benefits that you get from PEM, and many of the other factors that have helped us in our smaller units as we've competed against alkaline technology broadly. So we were surprised at the level of excitement, if you will, on the industrial side. And even on the megawatt side, we're seeing more and more entrepreneurs in Europe and in other parts of the world who are really looking at how to harness that excess renewable energy and to do something commercial for it. So in other words, it's nice to see commercial opportunities coming forward, and not everything is a government-funded, subsidized project. So we've been pleasantly surprised with that. We've got a number of active bids that are happening, and we fully expect that we'll begin taking orders for the megawatt unit as projects begin to close in the second half of this year.
And you just talked about funding. Was this project funded by some external organization?
The megawatt development was internally funded, so Proton did all this development on our own with our own internal capital from our current ownership structure. Some of the early development in our cell stack technology was funded through the U.S. Department of Energy, but really the full realization of the megawatt platform has been on our own developed, funded intellectual property, and we like it that way. It builds on what we've done in our other systems, so there's a lineage and linkage back to our earlier systems, but that's how we funded it.
So Toyota announced earlier this year that their new fuel cell cars, and that they were opening the licensing of their patents to everybody. I'd like to just have your opinion on what do you think this is going to change in the overall scheme of fuel cells and hydrogen distribution?
So I think our industry has grown up, many of the companies here, with being very protective on intellectual property, which made sense for a long time. But as you look at what Toyota's done on the car side, their goal is to open up the commercial marketplace and compete commercially. It's not going to be a patent war over, we're going to sue you for patent infringement here. That's not how you build a commercial marketplace. So I think Toyota opening up that technology is really a signal to the transportation side of the world on let's go get this going. I've been fortunate enough to drive the new Mirai. It's a phenomenal vehicle. We've actually had a program with Toyota going on for 4 years now with a fleet of their Highlander vehicles. We've had as many as 14 of them at Proton where we have a fueling station. So we're very familiar with the technology, and Toyota, similar to what they did with the Prius, I think is looking at the fuel cell vehicle in the same exact way in terms of how they're going to roll out this technology aggressively, bring it to market, let the public learn to really adapt to it, and let the penetration happen from there. So opening up the patent portfolio is a way to say, if there's things that other people can use to make the market happen, to get the volume of vehicles out there, then Toyota's comfortable competing commercially and based on the way they do it with all the rest of their vehicles.
And you were mentioning that you've been driving one of those Toyota vehicles, so you're from North America. So I'd like to know, because here in Europe we hear often what's going on here in Germany, fuel cell is really strong, but I think it would be important to get your views about how the same industry is developing in North America.
Yeah, it's interesting and it's very different. I think certainly over here, there with the global situation of a lot more renewables on the grid broadly, approaching 30% here in Germany. Many of the problems with renewables on the grid, with stranded assets and the imbalances between the renewable energy generation and the use. Energy storage is much more of an acute problem here than it is in the United States. Also, I think with the CO2 regulations and just the overall concept here of green being important and CO2 reduction, those again are helping to drive the market here earlier than what I believe is in the U.S. We're fortunate that we have the first power to gas project going on in the United States that we announced yesterday morning as well. And we believe that the United States will get there, but the U.S. is still very battery focused, and batteries will be part of the equation as we look at energy storage broadly, and we're fine with that. I also think that President Obama, when he first came into office, had a Secretary of Energy that was also very battery focused, so that kind of pushed hydrogen a little bit further down the agenda. That's been somewhat changed over the last 2 or 3 years, but as we all know, things, once they start to move, they tend to move, undoing them takes a little bit of time. So the U.S. is getting there, I think, as it relates to transportation, certainly California and in some of the northeastern parts of the U.S., there will be vehicles coming in this year, next year. But again, I think Europe will really set the pace on energy storage for megawatt. And then I think the U.S. will certainly be a large market that follows behind it.
So before I ask, I just want to remind, does anybody have any question that you would like to ask Mr. Friedland? And in case you're just too shy and you want to talk further one-to-one, I invite you to go to their booth, which is located right behind us at C70. And you mentioned that your power-to-gas project down in California. Could you give us a bit more details of what this project is about and what's coming up next?
Sure. Well, Southern California Gas, one of the largest utilities in the United States, certainly in California, they wanted to really understand how electrolysis works within their system. They're going to be doing some combination with CO2 to create synthetic methane. And in some cases, they're doing what I think many people here, from Fraunhofer to projects that have been going on for several years, would say, well, we did that 4 or 5 years ago. But it is an important step for these utilities. They're working with the National Renewable Energy Lab. They're working with the Fuel Cell Research Center at the University of California at Irvine. So I think there's a group of people that are really using this as a way to study it, to understand how does it go, how does it broaden, and how does it fit sort of throughout the application. So I think it's again a little bit where Europe was a few years ago, but it's an important first step for the United States, and it's important for us to be a part of it and to also be affiliated with a lot of the folks in the U.S. who are really going to write reports about it and use it as a model for where we can use it best in the U.S.
Well, like you said, North America is a very different market all in all. So sometimes you have to bring those projects to completion at home, right? So that before they get accepted, and then that brings me to one last I'd say, point. We know from previous year here that Connecticut is usually a hub in the fuel cell and hydrogen industry. Would you see that this power to gas project in California could be duplicated and Connecticut would be the next point of expansion?
I mean, it could be. I think it really depends on your utility needs. And in California, they have a lot more renewables on the grid than we do in Connecticut. But there are places in the United States now where they're having issues with renewables, like in Texas and in other parts of the country, where I think they'll be looking at this technology and this demonstration to really mimic to see where is the next best place to put this in the United States, and I think it'll act as a feeder into the electric power industry broadly. We want it to be used in places where it's needed. It's great to do these demonstration projects, but again, we need to have a market that develops that will accept these units for the commercial benefits that they bring to the table. And I'm hoping that this is sort of that launching pad to.
Well, you have industrial customers that see a lot of interest in your product already.
That's correct. Yes, we do sell our industrial products all around the world, and we're in 75 different countries. So beyond the renewable power to gas side, there is a very large growing business in our industrial side, all PEM. So I want to be clear that Protons, for our 18-year history, we've always been PEM as it relates to hydrogen generation. It's something that those of us, I'm one of the co-founders who started the business, always believed in the advantages of PEM and the scale and the cost and the efficiency and the low temperature and the safety and the footprint and many of the things that you get with technology. And really, it's been this evolution through these different commercial markets that we're in today and the proliferation of these products. We have over 2,000 installations around the world. So the megawatt is an extension of business that we already do. We're ready to move it into the commercial marketplace and sell it to folks with real commercial warranties and back it up with the technology that we've been doing for 18 years now.
So unfortunately, we're running out of time, so I'll have to thank you. But for whoever is ready to buy a megawatt electrolyzer, just go next door right behind us. They're ready to take your order. Thank you very much, Mr. Friedland, for your time. It was greatly appreciated.
Great. Thank you very much. Thank you.
And stay right back. We have more coming up with Abengoa renewable hydrogen, energy storage and security of supply coming right up. Thanks again.